Hello everyone, in this video I'm going to do experiment about resistors in series. Objectives: to determine the equivalent resistance of three resistors connected in series. Apparatus, power supply, switch, connecting wires, 4 voltmeters, 1 ammeter, 3 resistors, known their values. 15 ohm resistor, 20 ohm resistor, and 5 ohm resistor. Set up the circuit as shown in the diagram. We adjusted the power supply to 4 volt. But we use extra voltmeter to measure the voltage of the power supply that we used. It is the terminal voltage. So we start to connect, switch off of course the power supply. We connected the power supply to the voltmeter. This here 30 volt. So we use the values up to 30 volt. And then I check the power supply. Here 1, 2, 3, it's 4 volts exactly, the same as the power supply. From the positive terminal of power supply to the switch. And from the switch, let this resistor is R3. It's a 20 ohm. And from R3 to R2, I use this R2, it's 15 ohms. And from 15 ohms to the third resistor, which is R1, 5 ohms. From 5 ohm resistor to the ammeter. Finally, from the ammeter to the power supply. I check the circuit. I rechange here. Yes. So this is a connection. This is a series connection. So you can see here the voltage here exactly. When we take the reading, we have to look direct to the needle of the voltmeter or ammeter. Now here it's 1, 2, 3. It's less than 4 volt. Not 4 volt as a power supply, because this is the terminal voltage. The voltage of power supply, it is EMF. But now here, the terminal voltage, that the voltage we use, it's less than 4 volt. We connect the voltmeters in parallel to each resistor. Let this voltmeter connected to R1 in parallel to R1. I check the connection after each value. Yes, it's okay. The second voltmeter to the second resistor, parallel, in parallel, of course. I check the connection, press on. Oh, here we have to switch this. Yes. Now I check the last one, the voltmeter connected in parallel with the resistor R3. I have to switch this also. Yes, the connection is perfect. Now we take the reading. This is R1, it's 20 ohms. R2 is 15 ohms. R3 is 5 ohm. The reading of voltmeter here, I read that reading here. I have to look normally. Now it is when I switch on. So the reading of voltmeter drops. It is not 4 volt because it is the terminal voltage. So I take the reading of voltmeter when I switch on the current. Now it's here 1, 2, 3. It is 3.9 volt. So the main voltage of the circuit, it is 3.9 volt. We find the reading of the current also here. It is 1 dash before 100, so it's 90 milliampere. So it's 90 times the 10 power negative 3 ampere. We take the reading of each voltmeter. So V1 is 1.75. Remember this 20 ohms. The voltage, it's 1.75 volt. What about 15 ohms? So it's 1.3 volt. Note that when the resistor decreases, the voltage also decreases because it is the same current. The last reading when the resistor is 5 ohms, so it is 0.4. So V3 is 0.4 volt. The resistance of the circuit, it's V over I. V, the voltage from the power supply or the main voltage is 3.9 divided by the current of the circuit, 90 multiply 10 power negative 3. The resistance here 43.3. This is the calculated resistance 43.3. What about the equivalent resistance? The equivalent resistance is R total, which is 15 plus 5 plus 20, it's 40 ohms. Now we can compare between the calculated resistance, it's 40 ohm, the calculated resistance is 43.3 ohms, and the equivalent resistance. 43.3 divided by 40, it's 1.1. It means the calculated resistance is 1.1 times more than the equivalent resistance. What is the relation between the voltage drop across each resistance and the voltage drop across the circuit? So the voltage drop across each resistance is 3.45 volt. And the voltage drop into the circuit, it is 3.9 volt. So the voltage drop across the resistance is less than the voltage drop across the circuit. 3.45 divided by 3.9, it is 0.9. Then the voltage drop across each resistance is 0.9 times less than the voltage drop across the entire circuit. So we did this experiment to verify that R total is equal to R1 plus R2 plus R3 when we connect the resistors in series. I hope you understand this experiment. Thank you.